All right, combining functions. So if we look right here, these are our objectives for today. Perform arithmetic operations on functions. Arithmetic just means add, subtract, multiply, divide. Can you do that? All right. Then we're going to talk about function notation, and we're going to do composition of functions. Okay. So we're going to start off with a word problem. Why we start off with a word problem is because you guys usually don't like word problems. And I start off with them to show you that it's really not that bad and it's not that terrible. It's totally doable. Okay. So if a driver with a reaction time of 1.5 seconds attempts to stop while traveling at X miles per hour on dry level pavement, the reaction distance is modeled here with R of X equals 11 divided by 5 times X, okay? The braking distance is B of X equals 1 over 11 X squared, okay? Where both distances are in feet. So write a formula for a function S in terms of Rx and B of X that gives the stopping distance when driving at X miles per hour, okay? So we want to know what has to take place when you are braking. Like how are these two going to be combined? Well, usually your 55 is your X, right? So it's saying that if you are speeding, you're going 55 miles per hour. How is that going to affect you to stop? Your reaction distance and your braking distance. So if I just wanted to know, period, how would you calculate that? What would you do? If I say 55 miles per hour, what would be my reaction distance? What would you do? You plug in X 55 for X, right? If I asked you what would be my braking distance, what would you do? Plug in 55 for X, correct? Because I'm giving you the X value and your job is to plug it in. So I'm going to pause. I would like for you to calculate 55 and then we're going to talk about it. Okay, so for your R of X, so for the first part, we're going to do R of 55, right? And what do you get for R 55? 121. We got 121 because it becomes 11 times 11, right? Mm-hmm. All right. And then B of 55, what'd you get? 275. You got 275. When you are trying to stop and brake, don't you have to do both of these things? So if you're looking for S of 55, S of 55 would be you combining both of these actions. You have your reaction and you have your braking. So you would be combining both of these things together. So you would equal 121 plus 275. Does that make sense? Because you have to react in order to brake. Agreed? And that's going to... Huh? How do you know to react? How do you know how to brake if you're not reacting? You're just going to be braking while driving for no reason? No, it's you stopping. It's saying, so the driving reaction. So it takes 1.5 seconds to attempt to stop while driving at 30 miles per hour on dry level pavement, right? The reaction distance is R of X and the braking distance is boom, right? So in order to stop to speed, so it says S in terms of R of X. So what is your stopping distance? So you have to react and braking is how you stop, right? So your S of X equals you reacting and you braking. Yes? And that's going to cause you to stop. And that equals 396. Yeah? So how many feet away do you need to do? UB. I said the UB. I can't even talk. So if you're going 355 miles per hour, roughly, it's going to be 396 feet for you to have adequate amount of time to stop. Without slamming on your brake. Like, ah! I don't know. I think so. My progressive is low. So I'm going to say yeah. All right. So when you graph these, you would see how they're growing. So when I'm graphing, this one would be a linear situation, right? So this is a linear graph. This is a quadratic, agreed? Yes. And how do I know they're linear and quadratic? Exactly. Exactly. Power of 1, power of 2, right? And when I add them together, that means I'm going to make another quadratic because now my leading power is still 2. So my speed, the slowing down would be 2. So now if I'm needing to figure out for each one of these, instead of having to plug in each time, I can just combine those combined in the calculator. So let's look at our calculator. So now we've established in order to stop, you have to react and you have to break at this, like, yes. So if I want to make a table of this, I'm now going to put both of them in the calculator together. So I have 11 fifths x plus 1/11. I put too many pluses. 1/11 x squared. So that's my stopping function. If I hit graph, it's gonna draw a part of the curve. Now I want to look at the table, and it's specifically giving me values for my table: 11, 22, 33, and 44 and 55. To change my table so I only see those values, I'm going to hit second, table set, and I switch from auto to ask. So now I can create a table that shows those values. So we have 11, 22, 33, 44, 55. Okay. How do we feel about the table? Was the math terrible? You just had to use the logic behind the math, right? But the math itself is 100% doable. Agreed? All right. Okay, now we're going to talk about composition. So I'm going to clear my calculator. So composition, math composition, not English composition. Math composition is when you're putting a function into a function, basically. You're composing, right? You're making beautiful math, all right? But it means that it's two-part math. So this right here, this is an example of addition composition. I'm adding the function to itself. So when I'm looking at this, you're looking at the value. So it's saying if I plug -2 into G and into G again, and then I add them together, what's going to happen? So if first thing first is I'm going to find what is G of -2. That gives me -2 plus 3. And what is -2 plus 3? 1, right? I didn't hear you. I didn't hear you. I didn't hear you. I did not hear you. So now if I know that each one of these G of -2 equals 1, all I'm asking you is what's 1 plus 1? 2. I did not hear you. All right, same thing here. I'm going to plug 0 into F and 0 into G, but this time, instead of adding my results, what am I doing? Subtracting. So F of 0 equals 0. Agreed? Because it's going to be 4 times 0 minus 0 to the, which is what? 0. Now I'm going to do G of 0, which is going to be 0 plus 3, which is 3. So now what am I doing with these two results? So I have F minus G, which equals 0 minus 3, which is -3. How do we feel? Tired? Yes.
Like that confused me. I thought I was supposed to add x plus 3 plus x plus 3. And then like that times maybe 2.
All right. So these were examples of addition and subtraction with composition of a number. How do we feel? Huh. Paying attention to me? All right. Well, what are you not grasping? Close your laptop. Uh-huh. Okay. What are you not grasping? Tell me. Yes. So the number is telling you what you're substituting in to the function. So what are you, function notation, substituting in. And when I substitute that in, I get a value. And then this tells you what operation you're doing. So this says, I'm going to add that value together. So I had 2 G's. So that means G of -2 is 1. So I add 1 plus 1. Okay. All right. Now, do you think that division, not division, multiplication and division are going to work any different? No. If you said no, then you were correct. Okay. What I am going to model here is that you can do it all at once if you choose to, instead of doing it in parts. So if you're doing G times F, that means you have X plus 3 times 4X minus X to the third, right? That's the G times F part. Agreed? Yeah. Now, this tells you that for every X, you're going to turn it into a what? 1. So now this becomes 1 plus 3 times 4 times 1 minus 1 cubed. Ariel, you good over there? All right, so then we're going to add. So we have 1 plus 4 is, 1 plus 3 is 4. 4 times 1 is 4. Minus 1 is 3. 4 times 3 is 4. So either you can substitute first and then multiply, or you can multiply and then substitute. Huh? Okay, so I just wanted to show you that either way you go about it, as long as you're still evaluating correctly, okay? So again, if you choose to do G of -3 first, and I plug in -3 plus 3 and I get 0. And then you do F of -3. I plug in -3 times 4 minus -3 to the third. I'm going to get -12 plus 27, which equals 15. And now I have to divide them, right? That's the G divided by F part. So what is 0 divided by 15? 0. 0 divided by anything is what? 0. Let's not put too much thought into that, guys. Like, dude, let's not. Don't listen to him. All right. So again, totally up to you which way you want to approach it. Okay, the last way I'm going to show you on how to do these is using the calculator. So in the calculator, you would graph both functions. So I would graph x, 4x minus x to the third. That's my F1, my Y1. And then I'm going to graph x plus 3. Okay, and then I hit graph. I'm going to let the graph do its thing. Okay, after I graph, then I'm going to be like, okay, if I want G times F, I'm going to find G and F and multiply. So that's where you press the trace button and you can type in 1, and 1 is 3. See that? And it's going to say 1 is 3 on this graph. To get to the other graph, you go up or down. So you use the up and down key to move it up and down. So clicking through this, toggles between. So on this one, again, trace, press 1, and one graph is 3. So I would remember 3. Now I'll go to the next graph, hit trace, press 1, hit enter, and I want it to stay on there. Go to the other graph. And I would go to 3. Why would it stay on there? Okay, this calculator is making me mad. Let's just go look at the 2. If I go to 1, what do I get? I get 3 and 4. And what do I want to do with 3 and 4? And what's 3 times 4? 12. That's how you use the calculator. Okay, same thing here. If I'm at -3, so I'm going to go to -3. Go to -3, and I get 0, and I get 15. What's 0 divided by 15? 0. That's how you use the calculator. Okay, using it as a graph. All right, next it says to find the domains of f of x and g of x and find the domains of their composition. So notice this time that we no longer have, what do you call it? These things. Numbers. You no longer have numbers here. You just have x in its place. So it's wanting you to create a graph or a function. So we're going to put in the first one. What did I put? So we're going to do we're going to do f plus g of x. So I'm going to type in x squared plus 1. And I'm going to type in square root of x minus 1. Now, what's kind of nifty about this calculator is that if I'm looking for f plus g, well, that's my y1 and my y2. There's this button called vars, and you're going to go over to y vars. You're going to go over to functions, and it'll allow me to say, I want this function plus, and I'm going to do it again, y function, and I need 2. So it allows me to put in y1 and y2, and this lets the calculator know that I wanted to graph y1 and y2 separately, but I also wanted to do what with y1 and y2? Add them together. So I'm going to click on graph. There's my y1. There's my y2. And then it's kind of hard to see, but it's them together just overlapped. Yes, you have to click vars. So you click vars and you're going to go to y vars and then you go to function. And that'll tell the calculator. Now, if you only want to see that one, you can turn it on and off by using this. So if I only wanted to see my combined one, I can make it dotted, dashed. I can change how they look. So I'm going to make this one a dashed one. So you can see so I'm going to make it dashed. So all I did was arrow over and click enter. Make it dashed, dotted, whatever you want to call it. So now I can clearly see that these are the originals. And then the other one overlapped it again. It keeps overlapping. Don't make me mad. You kind of can. Not right now. All right. So now when I describe the domains and everything that's taking place, I can kind of look at it and be like, okay, well, I created a square root function and I created half of a square root function here because it has restrictions on it. Let's see. I can also make it bolder, more. So you can make it bold. There's a lot of things that the calculator is useful for. So those are my 2 originals. And then boom, there's my new guy made very bold. So when I'm describing the domain and range of my sum, so the sum of these 2, the domain of the sum is from 0 to infinity. And if you're not sure, you can always go to the calculator, scroll over to your Y3, and notice that it starts at 0 and then continues. Do we see that? Okay, so that's my domain. And then the range of my sum, well, when I look at all the graphs, the range goes on for, starts at 0, well, -1. No, we're at 0. I can't even see. Was it +1? I'm sorry. Is at the top, right? Y is 0. It is at 0. Okay. It starts at 0 and then it goes on to infinity. So my range is from 0 to infinity as well. Oh, bad teacher. Parentheses. Never bracket on infinity. How dare I? I know. And then I can change it. So now I'm going to go back to Y1, Y equals, and I'm going to change it. So instead of adding them, I'm now going to do what? Subtract. She went homesick. And now it's going to graph. There are my originals. Now I'm analyzing the new one. Did much change? Can I tell it from the graph? If not, then I can go look at the table. Bless me. And I can see now that what changed was my minimum Y value. So my difference. All right. So the difference. Now we've done difference. We've done addition. Now we're on to product, multiplication. So we're going to look at the product of them. So if I go down to my Y1 minus my Y2, now we're going to change it to a multiplication symbol. So I'm going to go to graph and see what happens when I multiply. So there's my originals. Oh, and then there is my multiplication. I feel like I should zoom in. Man, y'all are killing me. This school year's been loads of fun. All right. So it goes. So as you can see here, I come all the way down here to -1. It looks like, right? What about my domain? Where does my X start? X starts at, does it start at 0? Let's look. Let's look at our table. Is there a value at 0? Yes. So where does our domain start? 0. So for the product, we're at 0 and we go to infinity. The range, we are all the way down at -1 and we go to infinity. All right. Lastly, we have our quotient. So looking at the quotient. So I'm going to go back over here and I'm going to change from multiplication to division. And I'm going to hit graph. There are my originals. And ooh, look what happened with the quotient. Did some crazy stuff. So originals. Now look what happened with our quotient. A lot of things. It went down and then came back up. So let's look at the table of our quotient. So we're going to look at Y2 and Y3. Now, look at this. So it says that we are defined at 0, but are we defined at 1? No. That means there's a hole in our graph. Okay. So that tells us that for our quotient, we have, how can I write this correctly? So we're from 0 to infinity, but X cannot equal 1. Okay, and that's because there's a hole in our graph. So that's our domain. And our range, though. Uh-oh, sorry. Now let's look at the range here. So the range, the values are doing what? They're increasing. Let's look at our graph. And they just keep going, right? So they went down and then they came back up. So what do we classify that as? So it's a split, right? So there's our domain has, but our range is pretty infinite for the most part. So we went from negative, I think it's negative infinity. Nope, we don't start at negative. Sorry, guys.
But you supported her.
Yeah.
I'll make it.
I can't stand it. Gregory, be quiet. You're no longer allowed to talk. You're no longer allowed to talk. Don't laugh at him, guys. Do not talk to Gregory. So we start at negative 1 and work our way to infinity. Looking at our table. All right.